VoxelTrace, World-Aligned Surgical Motion Analysis and Review for VR Podiatry Training. Medical institutions are increasingly turning toward surgical simulation to reduce material costs and enable repeatable practice. Prior work has explored VR surgical simulations and its effects on student training. Beyond training itself, virtual simulation environments create opportunities for advanced analysis of kinematic surgical motion. In this work, we study a VR-ingrown toenail removal simulator with dual haptic devices that captures multimodal surgical behavior, including hand position, surgical tool angle, force feedback, and button press events. Yet, user evaluation in these environments often relies on instructor observation, replay, or fixed scoring, making it difficult to see where a trainee's attempt may have diverged from the goal and why. VoxelTrace addresses this by learning and forming its AI prediction through a world-aligned voxel memory. As the user's surgical attempt unfolds, multimodal information is written into 3D voxels along the user's path in the original workspace, allowing evidence to accumulate only in the regions the user visits. As evidence accumulates across the visited voxels, VoxelTrace forms its final prediction, classifying the trainee's surgical attempt as successful or needing review. Because the prediction is formed through these visited voxels, VoxelTrace produces a visualizable 3D map showing where the most important evidence formed and which feature signals, such as hand position or tool angle, contributed most strongly to the AI decision. Unlike traditional per-time-step saliency approaches, which identify important moments in a time sequence, VoxelTrace preserves where evidence accumulates in the surgical workspace over time. The same voxels can be revisited during a single attempt. Repeated interactions update localized evidence in those regions. This makes the representation more spatially grounded and more informative for post-attempt review. In this example, a trainee incorrectly performs the anesthesia ring block by reinserting the syringe into the same region twice. In the predicted minus support view, VoxelTrace highlights this likely error region as a localized red voxel, revealing failure-related evidence accumulated in the workspace. In initial feedback, a podiatry doctor noted that these voxel representations align with procedural expectations, localize meaningful surgical behavior, and could help support trainee feedback when compared with expert baselines. They also noted that guided explanation would help first-time users interpret the VoxelTrace visualization. For more details on VoxelTrace and its implementation, please refer to the associated paper.